Hello again. So we've now had a look at the equipment in the box and we have a little bit of an idea of how the Arduino Uno is arranged. We now need to learn how we're actually going to build our circuits. Now we could solder components together, but that tends to be very permanent. And if we're not sure exactly how a circuit's going to function, we want to test things, we're going to build our circuits on what's called a breadboard. In the old days, and I mean very old days, electronics, these were literally pieces of wood, breadboards that people drove nails into and then tied the wires onto. We've gone up a little bit in the world and we've got a nice simple plug board, which we still call a breadboard, to be able to build our circuits. So let's have a quick look at a breadboard and I'll show you how it's wired because it's not always the most obvious. So the breadboard is this white plastic block. I've got two of them side by side. That just gives me a little bit more space when I'm trying to do this under the camera for you. But we have two long rows running down each side, which we refer to as the power buses. Then we have internal rows and we have a central gap. Now, it's a little bit hard to see how things are connected easily on here. So I'm going to change to my other screen and I'll show you a digital version. This is our digital breadboard. Now our breadboard here has the same arrangement. 30 columns, numbered 1 to 30, and 10 rows, numbered or lettered A through E, and then F through J. All of these pins are somehow internally connected. Our power buses, and generally speaking we use blue or black for negative, are connected along that long line to start with. So all of those pins that I've just put that wire on top of are all connected together. But they're separate from all of those pins, which are also connected together. So I'll put those in a different color. The same is also true on this side. And what you'll often find is that when we build circuits, because we think of electricity as flowing downhill from positive to negative, what we do is we tend to think of this top rail here as being our positive rail, this red one, and this blue line down here as being our negative rail. Our electricity will then flow from here to here through components that we plug into the board. Now on the board itself, instead of being connected together in rows, they're connected together in columns. So all of 1J, 1I, 1H, 1F and 1G are all connected together. So if I put a wire in there, and let's make that yellow. Those are all connected together. You can also see if I click this one, those 5 holes all connected together automatically on the inside. So we could connect those. I'll pick another color to make it easy to see. But they're separate from these ones, which are also connected vertically. So whenever we're building circuits, we will tend to work from top to bottom. Power coming in on the red wire, on a positive wire, running through components, running downhill, and then eventually coming out here. Down the center is the gap. It's a physical gap. It's perfectly spaced for some components, and we'll often put components across that gap so that we can definitely not miss them out or wire them up wrong by jumping around. In the instructions for building circuits, I will suggest plugging components into a certain socket. For example, I might say place an LED, here's an LED, and put one of its legs into E10 and the other one would go into, I don't know, let's just pick a number randomly here, 8F. Now my diagram, E10, 8F, let's just move my LED. It would then sit across the gap. That's a strange wiring, but you can see how the green dots line up. So if I connect something in here, a wire in there, that will then be connected to those wires. So now power can flow in here, jump out through this orange one, down through the internal wiring, through the LED, through here, and back to a negative. What we'll then do is we'll connect these two rails to our Arduino to power our circuit. So just be aware that we'll use coordinates such as J10 or A20 to address the actual holes, or we'll use the top rail or the bottom rail. So we'll call these ones here rails, and we'll call these ones pins. Now I know that's a lot to take in, but as we build our first circuit and make our Arduino Uno actually start doing stuff, this will become more obvious, and the more you do it, the easier it will become. I'll see you in the next one when we actually build our first circuit.